features, and so many SPMs and automation domain. So I also completed my CSWE, SolidWorks Certified Expert in Design. So first of all, I thank you all for joining for this session. Today, as I thought of doing it for an introduction session, a basic introduction session about the product development processes, and also parallelly I thought of giving you a demo in this session. That's how the session is being planned. So what I will do is I will proceed with the entire session. At the last half an hour, we will have for a Q&A session where all your queries related to the session will be clarified. So first half an hour, there will be a presentation. I'll be showing it in slides. Then we will be moving on into SolidWorks and the other solutions like Visualize Connected to do rendering and to do the design, everything, and to do a small simulation also is being planned. So what and all we are going to cover is first is a quick introduction about product development processes and various steps involved in design processes. As I told, as I planned, it's a basic entry-level session. So from the basic textbook onwards, small calculations and a small design, everything will be, you can expect in this session. Then what are all the reason for the product failure that we are going to understand. Then the case study on a new product development, which is nothing but, as we informed, a conveyor design will be studied as a case study. So first we will see what is engineering design. What is engineering design? It is a process of converting idea or a market need to a detailed information. Whenever a product need to be developed, it involves so many processes. But in that, one of the processes design, that is called engineering design. Usually engineering design comes through engineering drawing also, I can say. We all know that engineering drawing is nothing but it's a universal language of engineers. We sit globally around the world, and we do design in one country, we do manufacturing in one country, assembly in one country. Everything happens through drawings itself. We do communication, everything through the drawing itself. So drawing is a key, and engineering design process is the main part of creating the drawings for the engineer. So this process involves a series of steps that engineers follow to come up with a solution for a problem. So why we do the design? We want to address some solution. So that solution, to address it, we do the design process is the key. Many times to address the solution, it involves designing a process, and the product has to meet the end user requirement, and it has to fulfill the requirement. A product will be developed. That's what we call it as a new product development. Again, the design process is a systematic problem solving strategy with criteria and constraints. It has some criteria and constraints that anyway we are going to see. Finally, it has to fulfill the requirement of end user. Now we will see what is meant by innovation and invention. Innovation is the process where you will be improvising something when some solution is already available to the latest market trends. You will be improvising and providing the solution to your customer. That's what we call it as innovations. Invention means there is no such something earlier. You have developed some solution to the customer, that we call it as an invention. So new product development sometimes fall in innovation and sometimes fall in the inventions also. So now we will see there are many steps available in the engineering design process. So some of the textbook solutions has been given is, first step, they are saying it, identifying the problem and opportunities. Why we are going to develop this product? That is the first question. It will be, who is the end user? What they are going to do with this product? These are all the questions. It will be there in this first step of identifying the problem. So for an example, a simple basic example we will take. If you are planning to develop a pen, what is the use? Why the user has to buy my product? So pen will be available in the different market categories and different kind of peoples. For example, the pen will be available in the low cost also. It will some in the mid range, some will be in the very high cost. What range of customers you are targeting, that need to be identified here. Then some of the steps has been mentioned, like framing the design in brief. So what should be the diameter of the pen? How much should the pen should write? Some will advertisement says like my pen can write this many kilometers, so and so on. And main thing here is some solutions might be sometimes already available in the market. You will be developing the same solution again. What should be your unique selling point? What you are improvising from the existing solution? That plays a major role in the successful product development. So that's what you do in the framing the brief, design brief. So what and all the features you will be including in this particular product, that will be discussed there. Then investigation and research, what and all the existing products are available and what betterment you are going to do in your product that you are going to develop here. And generating alternate solution. Is there any other alternate ways we can address the problem? That also will be involved here. Then choosing the right solution. If you generate for the same problem, you can address in multiple ways through a brainstorming base. So after brainstorming, you will be collecting, gathering and getting a collective ideas. Then you will be addressing the solution. So then you will be choosing the correct solution. Then the development work, which includes the modeling and prototyping. So the first product development which used for testing, we call it as physical prototyping. Virtual prototyping is also involved, which is nothing but finite element analysis solution, like CFD analysis, FEA analysis, and electromagnetic simulation, EMIMC analysis. So all these simulations, virtual simulations also falls in. Then you'll be testing and evaluating, redesigning. Once you find the physical product result, there may be sometimes some redesigning, some improving options will be there, that will be taken care. And so many authors are there, they will be saying so many things, but almost everyone, what we see is the same. The problem identifying the need falls in the frame criteria. So whenever you want to design some product, the need identification is very important. Then how you define the problem, then synthesis, analysis and optimization and evaluation. This flow chart shows some of the things. Suppose you identify the problem, then you define the problem. So you identify that you are going to design some pen or a machinery or any product can be. So what does it going to function? You are defining here. Then comes the synthesis. Synthesis is nothing but what should be the diameter, what should be the length, the kinematics and dynamics parts comes here. Okay, which is nothing but the motion simulation, also the length, width, height, the overall dimensions, everything will be falling in the synthesis. Then comes the analysis and optimization, which is nothing but it can be finite element analysis, everything, motion analysis, everything can be to optimize the product, it will be done. Then finally, then comes the evaluation. So once it is done, you create a drawing and you do the evaluation testing. Then before selling it, you do a photorealistic rendered image. For aesthetic purpose, a good presentation is also required. So that also has been considered. In any of these, if something is failed, you have to go back to the previous step and you have to reiterate and you have to start again and you have to come down. So first we will see about identifying the need. So what and all need to be considered here. So what your product want to be do, that's what you are going to consider here. Then what are the requirements for product development? What are the requirements? What are the limitations? And who is your customer? These are all the basic questions you need to understand. There will be many other questions, but at least these questions if you have to identify for the new, whenever you are going with the new product development. Then the defining the problem states, you will be arriving at the specification. Suppose, as I told, if you are developing a gearbox, for an example, what is the gear ratio and what is the overall dimension, what is the mounting frame dimension. So all kind of the specifications, the data sheet, whatever we say, that will be arrived here, and also fixing the constraints. There will be various sizes of the gearboxes so how compact it is, the more customers you can attract, or how what is the key factors or advantage benefits you give to the customer, that will be done in the fixing the constraints. And research and gather data, he will be similar products, whatever, how earlier the customer is addressing that particular solution, everything you'll be gathering the data. Then brainstorming and generating idea. So instead of single idea, if the multiple people sit together and if they come up with different solution, they will be having a multiple solutions. Then it is easy to evaluate and come up with a best idea among the multiple solution. That can be done through this brainstorming. Then finally, you will be selecting the best solution among that, and you will be proceeding. As I told, in the design synthesis process, you will be fixing the limitation, mainly the sizes and capability and performance requirements will be finalized here. The kinematic and dynamic simulation, what should be overall length, what should be the overall length width, everything, and how it's functioning, how the movement will be, how the motion will be, what kind of mechanisms will be, everything will be covered in the design synthesis. Then comes with the analysis and optimization. Initially, you will be developing some concept design just to make sure to convey that this is going to work. But in the analysis and optimization, for an example here, one of the topology optimization criteria has been shown here. The initial design has been shown. Then using the topology optimization, which is nothing but by applying the load and constraint, where and all exactly the material is being required. That area is being alone captured in a finite element analysis only. And based on this result, the optimized design is being created. Material saved, a single gram saved in each part. Suppose if you are manufacturing lakhs of the parts, the cost saved will be huge. So this area is also very much important. And also you are ensuring that your product is not going to fail. And also you are ensuring that you are designing with required factor of safety. Then finally, you will be evaluating your solution, whatever the product is being developed, whether it's performing as per your requirement. Sometimes it may overperform and sometimes it may underperform. If it is underperforming, why it is, you will be evaluating. And finally, presentation. As I told, the product may look good and it functions very good. If the branding and packaging is not good, no one is there to purchase it. So ergonomics part and the aesthetic part is also very, very much important when in the product development process. Ergonomics is mainly depends on the usage. When the user uses it, how comfortably you use without any putting more effort, with minimal effort or with required effort, he has to function it effectively. The product has to function effectively. For an example, if you take a pen, the pen has to be the diameter of like 15 to 18 mm. If you design with some 25 mm or 30 mm, you cannot able to write continuously. So the required diameter, so that the user with less effort, he can able to perform his task. That's what we call it as an ergonomics. And the aesthetic is looking good. Just like you can able to see when you create a design, it's look good. When you give some colors, textures over it, so people will attract more and they start purchasing more. That's what we call it as an aesthetic improvement of the design. Now we will see some of the reasons for the product development failures. This is a funny way of explaining this. I just found in internet. So something need is being identified like this, and this is how is being the product is defined. So in an organization, there will be a multiple departments. Starting from, for a product department, it's not only the design team is going to work. It will be like design team, manufacturing team, R&D team, sales team, marketing team, quality, assembly, and so many teams all put together work and they develop the product. Suppose when the need is identified and when the problem is not properly conveyed, some people will understand and they work on the different way. And the design again, it's not been conveyed properly. It is being carried out in a different way. and the assembly person, to an assembly person, how it has to exactly assemble. If it is not been properly conveyed, then they themselves will do on their own way. So all these stages, when the documentation, so whatever the process is being followed out, how the testing is being done, what is the results of the QC results, quality control results, everything, if it is not properly documented, again, that will be the chances of product failure. Then the cost spent on the product, how we spend, that is also important. A successful product development involves is keeping a profit margin in a proper profit margin by providing a proper customer satisfaction. You have to provide a right customer satisfaction or customer delight with your product, whatever you created. Then what is the end user? Finally, the end user requirement will be different. So any of these can be lead to the product development failures. Okay, and now I would like to move with the conveyor case study. So conveyor case study also initially, so like 5 to 10 minutes presentation will be there. After that, we will go ahead with the explanation in live demo in the SolidWorks. So first we will see what is the conveyor and what is the basic calculation involved in the conveyor. Then how to design the conveyor, a simple conveyor I will design and I am going to show you. And also I am going to do a static simulation, like a finite element analysis, the basic entry level simulation, we call it as a static simulation. Then we are going to do a rendering, creating a photorealistic images. Before doing the actual product, before the actual product has been manufactured, so we used to do marketing. Then we will be requiring the rendered images that will be created through this rendered images. So we will see the first one. We all know that conveyor. Again, a quick introduction about conveyor. It's a belt system. Conveyor system consists of 2 or more pulleys, minimum 2 pulleys required. Sometimes in the middle also so many pulleys will be added. It will be having an endless loop. So the conveyor belt, which kind of constantly rotating onto the conveyor, so which has an endless loop. So upon that conveyor belt, whatever we place, it will transfer the object or the parts or the whatever we place, it will be moved to one end to other. So the conveyor pulleys are usually one end powered or sometimes based on the torque requirement. So both end also powered or multiple powering arrangements will be there. So there will be 2 pulleys. One is driver pulley, whichever the pulley is being powered, that we call it as a driver. The other pulley will be driven pulley. So mainly the conveyor used to handle for moving the boxes in the factory and some bulk material handling, which includes large amount of material, agricultural material or grain, salts, coal in the ore or the mining area. So many applications are there in the conveyor. Some of them we have discussed here. So coal has been conveyed here, and here in the industrial application where some NDT testing, the material is being passed, and here the food grains has been transferred. Like this, so many industrial applications are there. So we are going to take some simple conveyor and we are going to work on it today. So as I told, we decided we are going to design the conveyor design. We have to fix the constraints. What is the constraints we are fixing is the belt and roller. It has to some mass, and what is the mass need to be transferred. Everything, the mass need to be transferred is important. So that is 50 kg, and the belt and roller mass comes somewhere around 30 kg, and total mass to be transferred by the conveyor will be 60 kg. The total mass, the self weight is 10 kg, and the mass to be transferred is 50 kg, and the total mass which is moving will be 60 kg. And there will be a coefficient of friction plays a major factor. Coefficient of friction is nothing but whenever we keep work on some ice, the friction will be very less. It can smoothly we can able to move. Whenever we walk on some rough surface, we cannot able to walk so smooth as we walk on the eyes. The reason is the friction. The friction plays a major role. It comes with the two materials which is coming into contact. For an example, the lubrication, why we do is mainly to reduce the friction. Sometimes in the bearings, if you see, in the balls will have a single point contact, and the rollers will have a line contact. So all these things, why we use the bearings is to reduce the friction. So all these things, what it does finally is it improves the value of coefficient of friction, which means when the coefficient of friction values increases, you need more force or more torque to move. Or when the coefficient of friction reduces, it can easily move. So here the roller material is considered with steel, and the material of the belt, conveyor belt, is considered as rubber. So the coefficient of friction is 0.4 has been arrived. The next step is we are finding the force. So the force has been found easily, like FA plus FEA is nothing but axial force, mg, mass into gravity, sine theta, mu cos theta. Mu is nothing but the coefficient of friction, and cos theta, the theta is nothing but the angle of inclination. So there are conveyors which is completely horizontal. For an example, this is the conveyor which is completely horizontal, and this is the conveyor when we see it is at some inclination. Okay, so when there is some inclination, we have to provide the angle. When there is no inclination, we have to consider it as a 0. Okay, so FA is nothing but if along with the movement, if there is some additional force. For an example, if the conveyor, when the conveyor is moving, some brush is coming and cleaning the part. So that is acting as an external force. The brush will come and rub the part. Suppose the part is moving, some brush comes and rub the part so that the parts get cleaned. So it applies some force over it. This force, we call it as a axial force. That is the external force which has been acting. That can be added. Here, just now we are considering that the conveyor is simply moving on the object. There is no external force, so that the values has been considered here 0, and we know that we consider the mass as 60 and the gravity is 9.81 Newton per meter square. Then the theta value, when it is completely horizontal, the theta is 0. We consider two cases. One is completely horizontal, one is at 45 degree. So when it's completely horizontal, we evaluate and make it as a 0. When it is 45 degree, we put the value for 45 degree and we find the force F. We all know that the torque is nothing but the force into distance. The force into distance is nothing but the torque. So when it comes as a diameter, we see like FD by 2 nu is nothing but the efficiency of the system. Whenever we buy some product, any product it can be, when we see it, it cannot function to its 100% performance. There will be loss due to the friction, heat and wear. So these loss of the system also will be considered here. So when instead of considering the 100%, we may be considering like 80% or 70% as per the specification or specified by the manufacturer. And I is nothing but velocity ratio, gear ratio. So we all know, like a simple example, this gear ratio plays a major role in increasing and decreasing the torque. Suppose 1:10 gear ratio, which means a pulley has like 10 mm and the other pulley has 100 mm diameter. So the gear ratio will be like 1:10. Or we will take a gear teeth itself. A pulley has 10 teeth and the other pulley has 100 teeth, means here also the gear ratio 1:10. Or if a pulley has 10 teeth and the other pulley and the other gear has 50 teeth, means again the gear ratio will be 50 by 10 will be 5. So 1:5 is the ratio. That's how we calculate the gear ratio in case of gears or a pulley. So what this gear ratio does is it will either increase the torque or sometimes decrease the torque also. Why the torque has to be increased? Because using the motor, in order to control the motor sizing, when you select some motor, the size of the motor has to be compact. That is the key factor. That's why we use the gearboxes or the pulley arrangement to reduce the motor sizing. Suppose you need 100 Newton meter torque. So you have input motor of 10 Newton meter. Then if you use 1:10 ratio of gearbox, what will happen? The 10 Newton meter gets multiplied with the gear ratio, which is nothing but 10 times. So one side pulley we say like 10 mm, the other side we have 100 mm. So the gear ratio is 1:10, or the pulley ratio is 1:10, which means it reduces the speed by 10 times. Suppose the 10 Newton meter motor into 10 times, you'll be getting 100 Newton meter as an output. At the same time, the 10 Newton meter motor runs at 1000 RPM at the input, means output you'll be getting 100 RPM, because the 10 times the torque is getting increased, the RPM, the speed is getting reduced because of this gear ratio. Okay, so again, the other assumption we made here is linear velocity of the mass. The part is moving it, but what velocity it is moving is 50 mm per second is the requirement, which means we already know the diameter of the pulley. So based on the diameter of the pulley, we can calculate using the formula pi dn by 1000. We can get like 30 meters. Pi is 3.14. Diameter is, we know the diameter of the pulley. N is the RPM divided by 1000. We'll be getting it meter per minute. So here we are doing nothing but linear velocity. We are converting into angular velocity. So the same calculation is being shown here, which is nothing but the RPM is assumed is 1000 RPM, and the 30 mm is the diameter. So pi into 100, we are getting the required RPM of the motor. The output RPM of the motor should run at 95.5 RPM, so that you can achieve the linear velocity of 500 mm per second. Okay, so your assumed motor speed is like 600 RPM, means the gear ratio required is 1.68, and 1.6 is being made as a round off value, and efficiency of the pulley arrangement or gear arrangement is considered as 70. So finally, we are finding the torque required at the motor. Okay, we substitute the value. We know the F value, which we found at the beginning itself, and the diameter of the pulley, and to efficiency and gear ratio. We calculate for horizontal condition, we required 4.2 Newton meter at 600 RPM. At the same time, when it is at 45-degree inclination, then our requirement is 10.5 Newton meter at 600 RPM. So the torque gets increased here. Here also, one more thing we considered is factor of safety also. Even though we considered efficiency, we should not forget that to consider this factor of safety. So again, when we see in the motor, there are so many torques are there. So initially there will be an acceleration, constant velocity, and deceleration. There are multiple types of motors are available. So in this broad or vague classification, if you see induction motor, I can say it will widely used motor where stopping position is not precisely required. Just it has to run and it has to stop. But whenever it stops, the position is not important. In that case, we have to go with the induction motor. For an example, pumps, water pumps, where water pumps doesn't require the precise stopping at exact angle or exact position. There we will be going with the induction motor. Example, in simple example, if you want to say still, means I can say it's a fan. In the house, we can see that in day-to-day life, we switch on the fan. The fan need not to stop at exact position, or it need not to start at the exact position. It will start slowly. So that's what we call it as an acceleration time. So whenever the acceleration happens, slowly it rotates. Whenever we switch on the fan, it won't reach its constant velocity immediately. It will slowly rotates, and it will reach its velocity. So those time we call it as an acceleration. Once it reaches the constant velocity, it will be there in the constant velocities for some time. That's what we call it as a rated speed. It has to run in 200 RPM, means when you switch on, it will take like 5 to 8 seconds to reach that 200 RPM. That initial 0 to the 200 RPM, the time taken, this time we call it as a acceleration time. At the same time, when you stop the motor, the time taken to reach from the constant velocity or the rated speed to the 0 RPM, we call it as a deceleration. Okay, so why we talk about acceleration and deceleration, that is that I like to tell you. The faster the acceleration is, the more torque will be required for a motor. For an example, now most of the automobile, they say like you will be reaching 100 kilometer RPM in 3 seconds or 2 seconds or 4 seconds, which means the very quick acceleration happening here. So for in that area, the torque requirement is very high. When the acceleration is very slowly happening, means the torque requirement is very slow. The fan, if you want to reach the time, now for an example, you will be taking like 10 seconds to reach the constant velocity. You don't want to take for 10 seconds. You need to do it within 2 seconds. Then the same motor will be requiring high torque. When you require high torque, the size of the motor, everything, the cost of the motor, everything increases. Based on the functions, the motors will be selected usually. So most of the time, the induction motor, you cannot able to stop precisely. Next, you can stop moderately or somewhat precisely using stepper motor. You can more accurately stop using the servo motors. The servo motor is the one where you'll be using that. You can very accurately stop it because it has an encoder and it is a closed loop circuit. It has. So we have arrived at the constant torque. Then, as we already found the angular velocity also, radians angular velocity by time, you'll be getting angular acceleration. Okay, so here we consider as a 1 second. So that angular velocity by 1 second, we are getting angular acceleration. Within 1 second, from 0 to the constant velocity it has to reach. That is the assumptions we have considered. Using that, we are finding the acceleration torque. In the motor, there will be multiple torque. One is acceleration torque and rated torque. So usually acceleration torque will be 2 to 3 times of the rated torque of the motor. So first step is we are finding the acceleration torque required. Further, the inertia plays the major role. What is inertia? Whenever some system is at rest, to make it motion, it requires more power or more energy, consumes more energy to get into motion. For an example, we imagine when there is a bus or a bus is idle, when we try to push and when we take it to a motion, it takes some time. But when it is in a motion, to move it further, the force requirement will be very less. The reason is initially from idle to give it a motion, due to the inertia, the force requirement is very high. So considering this, there will be a separate torque will be provided by the motor manufacturer, which is called acceleration torque. So that's the important. That's for that also, for finding the acceleration torque, which is nothing but inertia into angular acceleration. So inertia of the system, we know the mass of the system already. We identified like the payload is 50 kg and the total mass is 60 kg, like roller and belt together. So in that this 10 kg again we have splitted like 2 kg for belt, 4 kg and 4 kg for roller, and 100 mm for the roller diameter. These are the assumptions we assume. So based on our assumptions, we can able to find the inertia value using direct formulas available, which has been shown here. We are finding the inertia value. Then total inertia will be addition of all this inertia of the belt plus the mass to be moved and pulley. Even if it's a some different shape also, you can consider as a rectangle or the circle, and you can find the inertia, but consider it as an higher side only, and you can find the inertia. Then you can find the acceleration torque, inertia and the angular acceleration, which gives 1 Newton meter. So the rated torque requirement is identified, And peak torque. Peak torque is nothing but the rated torque plus acceleration torque will get you the peak torque. Again, here considering the factor of safety, we have arrived at the torque. Then the power requirement has been identified. So this is the motor characteristics torque. Whenever we are going to purchase some motor, means what and all the torque we have to see, that we are going to see this data sheet itself. You can able to see various torques. One is this dotted line represents the peak torque or acceleration torque. It comes for very minimal time only. It won't be there for more than like 2 seconds. Even some of the motor specification will limit to 1 second also. That is important. So initially the motor can deliver for up to 1 second. Up to 1 second it can deliver so 8 Newton meter also. After that it can deliver this continuous torque. You cannot constantly run on this acceleration torque. You can constantly work on this rated torque, which is nothing but for the continuous operation. Just to start and stop if you want to do, just within 1 second if your operation is going to complete, then this peak torque you can use, but you cannot continuously use this peak torque. This peak torque is overcome the inertia and to provide acceleration and from zero velocity to take you to the continuous torque. This peak torque will be helpful. So most of your operations will be done in the rated torque only. This rated torque also falls onto the graph, which is with respect to the speed. Whenever the motor is functioning, the byproduct will be the heat. This heat whenever this heat is generated, what will happen? The performance of the motor will keep on reducing. That's why you can able to see that up to 3000, it can able to give the constant torque of 2 Newton meter. After 3, it is getting reduced to 1.8 or 1.7 Newton meter. One more thing I like to highlight here is stall torque. At 0 RPM, due to the motor will be having so many magnets inside, which will resist the motion, and also so many seals to avoid the leakages, and so many parts will be in contact like bearings, everything, which have their own frictions. So the torque required to rotate on its own is the stall torque. At 0 RPM, if you give 1 RPM, so 1 Newton meter, the motor on its own itself will not rotate. Minimum 2 Newton meter torque, if you generate only, it will start rotating. But when it is in motion, when it crosses and comes to this position, even less than this torque, it will start functioning. That's what it is. That's the difference between rated torque, stall torque, and peak torque. Peak torque is very intermittent torque, which is nothing but very short duration. The torque will be there during the acceleration time and deceleration time. Here we saw now, I'm going back here, from 0 to reach the constant velocity, the torque required. This area, the torque comes in this, the peak torque. And also to the decelerate from the rated speed to quickly it has to come down to 0. Then again, so where exactly the precisely start-stop takes place? One of the example I can say is rotary index table. In the machine shop, you can see like in CNC machine, the index tables will be fixed for providing 5th axis and 6th axis, where the machining will be done. So it has to precisely stop so that you can able to machine sometimes in 10 microns accuracy or 20 microns accuracy. You want to machine some of the product, it has to precisely stop at precise position. Those areas, the servo motors are being used, where the precise start-stop is being used. At the same way, the conveyor also, when you see like when there is some operations are happening in the conveyor itself, some belts are being fixed, line production has been happening, so many automated welding or automated boring or machining has been happening. Those area, this servo motors can be used in conveyors also. So just to make you understand what is the difference between rated torque, stall torque, and peak torque, this graph has been shown. You can see like the stall torque is 2 Newton meter. Okay, and the stall current at 0 torque, what is the current required also is important. And rated torque is 0.75 rated output power, and rated speed up to 4000 RPM it can able to work. That's what is being shown. Again, this graph also we should take care. When you are working at 2000 RPM, you can work for 2 Newton meter. When you are working at 4000 RPM, you may have to work within like 1.8 or something. Okay, and the rotor inertia, which is nothing but again the motor itself has a inertia that is being provided, because the inertia ratio is also important. So this inertia ratio will ensure the proper stop and stopping. So when the rotor inertia will increase when there is a braking system, that is being shown here, and constant torque is being shown here. Newton meter per amps. Per each ampere, how much Newton meter it produces? 0.57 Newton meter it produces per ampere, which is nothing but the current. So here, the stall current is 3.5 amps. It has been given. So to reach the stall 2 Newton meter, you have to just multiply this. So each amps, this much Newton meter will be output. Okay, so these are all the some of the things. This brake, everything you can rest all is the basic things if you can read and understand. So these are all the some of the things you should take care in motor selection. So hope you understand about the motor selection for the pulley, whatever we have been selected and how it has been calculated. Now I will go with the demo in SolidWorks. So I have shared my screen, SolidWorks screen. I'm entering into a part environment. Before going to the SolidWorks, I like to give you what is SolidWorks. If someone asks, some of them are entry-level engineers also. If someone asks you what is a SolidWorks, what kind of definition I can give, you can give it like. Okay, hope everything is fine. Just checking. Fine. What if someone asks what is a SolidWorks? The basic or the simple answer can be SolidWorks is a feature-based modeling tool with parametric and associative property. So what is a feature-based property modeling tool? Why we say it's a feature-based modeling tool means whatever the operation you do, if you build a model or remove the model, remove something in the model, everything will be recorded in a feature like boss extrude, cut, revolve cut, a whole wizard using that, creating, everything will be recorded as a feature. I will show you. So each and every operation we do will be recorded as a feature. That's what we call it as a feature-based modeling team. And it's a parametric tool, which is nothing but if you want to do some changes, if you design some part with 100 mm, just click on the surface. It will show the relevant dimension. Some 100 mm, if you want to make it to 50, just double click on the dimension and make it 50, it will reduce to 50. That's what we call it as a parametric. It's a feature-based modeling tool with parametric and associative property. Associativity is nothing but in drawing, when we see there will be a part model, assembly model, and drawing creation. So most of the time most of the products will be of multiple parts are assembled together. You can take any of the parts around us, starting from the laptop or the mouse we have, or even the mobile phone, everything, the multiple parts is being assembled together. Hardly I can say it's very few products, entire products is completed in a single part. Most of the time it will be related to kitchen equipment like like a spoon or a plate. I can say it's an example of a single product. But most of the time, whatever we see around us is made up of multiple parts is being assembled together. So you will be creating a part drawing, assembly drawing. So whenever you initially you create a part and you assemble it in assembly environment, and you create a part drawing and assembly drawing. For assembly drawing will be there. For each part drawing will be there for manufacturing. Whenever you do some changes in the part, it automatically get reflected in the assembly. You need not to change it in the assembly environment, or you need not to change in the drawing environment. Whenever you do some changes in the assembly environment, automatically the part will get updated and drawing will get updated. This property we call it as an associative property. So the three major thing is it's a feature-based, parametric, and associative property is been included in the SolidWorks. Most of the CAD tools, it's not only for SolidWorks, most of the CAD tool, all these three features are included, unless it's a 2D modeling tool, which won't link assembly and suppose in AutoCAD, if you create a 2D drawing, then again, if you create an assembly drawing, if you edit something in the part level, again, you have to edit the changes in the assembly also. That is required there, because when it is not, when the software tool doesn't have an associative property, you have to edit in the multiple area. But when in some software like SolidWorks already has inbuilt associative property, if you edit in the part environment, automatically the assembly also get updated, drawings also get updated. That property we call it as an associative property. Okay, fine. This is the thing I like to explain. Now I will start with the sketch. So before going for any 3D model, a sketch is required. A sketch can be 2D sketch or 3D sketch. 2D sketches you will be creating onto the plane. 3D sketches directly you will be creating in the 3D environment. Now I will directly show with the 3D sketch. Later on, I will show some of the with the 2D sketch also. Now I am going to start at a frame. I need not to worry about the dimension at all. I just have to create the shape. So if I press tab, automatically you can see this cursor, this reference will keep on updated. So what I do is I make a rectangle here and 4 legs I create. I can see this plane is not the right plane. So I'm pressing the tab in the keyboard, automatically changes. And along X, I constrain it. Now I'm providing the constraint. And I can hold control and press these lines and give it as a parallel constraint. The same way, I just make sure this is along Y and making it parallel. So now relations and constraints I have given. Still, it is not completely constrained. How I know it's completely constrained is the blue color has to completely get changed into black. So now I give the dimensions. So the height, I assume it as 800 mm. The width, I can assume it as 600 mm. The length, I consider as 1000 mm. It became 100. So once again, I double click and change the value. Okay, still I can see this there is a blue color dot, which is not constrained, it's moving. Now, if I try to move this line, it won't move because it's completely constrained. So now I have to constrain this length also. How I'm going to do is just pressing the control. This is a fully constrained one. These are all the unconstrained one. I select all 4. There is an option called equal. If I give the command as an equal, it gets constrained. Now, leg connecting frame also, I just draw over here. Just pressing tab and changing the direction. And I give the dimension over for this also, this height. So I'll consider 200 mm. Now this is not constrained. So the reason is, you can see here, there is a gap. So I just select this point and this edge and give coincident. So when I give that relation, it gets completely constrained. Once I create here I needed to enter into weldment. So I just right click in this blank area. I can see here tabs. I can activate this weldment tab. You can see now this weldment tab is available. Same way, if I want to activate the sheet metal tab, just right click in this blank space. You can find this sheet metal. You can see that the sheet metal tab is activated. Likewise, you can activate or deactivate So it gets removed. So I just go to the Wellman tubular structure. So what is the size? What is the standard I have to use? Everything is model. We can customize this also. The customization part, we can have some other sessions also. As I told, I thought of giving some basic introductory session. Later on, we can have some advanced level sessions also. So I will go with some square tube itself. So 80 by 80 by 40. I selected. Here you can make a groups. So for making the group, this is something important. What you have to select is the linking of the tube is very much important. First I select the top 4. Then if I try to select here, it won't do. So what I have to do is, if the loop is completed, I have to select new group. It won't select. So what I have to do is, again, I have to give new group. You can see the difference at the top. You can see it at 45 degree. It only consider the manufacturability point of view and the strength point view also. So after creating this, I selected this loop. That's why you can able to see it got stopped between these spaces. Here, before creating this, I created this. So once this is created, it got stopped. This one got stopped at this space, bottom of this space. Very quickly, very easily, I just created in few minutes. Suppose if I want to increase the length, just double click here. As I say, it has it's parametric. The length got increased. And the sketches, if I want to hide, I can hide. And I will just make it as plain white. Okay, now what is required is the legs is required. I create the legs also. If it is movable, you may have to use the caster wheel. I go to rectangle, there is a center rectangle option. You can select and give the rectangle over here. And even the sketch mirror option is also there. So all I have to do is to have a center line. Then the mirror option I use, I select here. Again, I select, create one more center line over here. So then I go to extrude. So whatever the thickness I required, I can add. Okay. Next, there will be I create a plate, which is nothing but the roller mounting plate. And I'm going to create a 2 rollers only. With the 2 rollers, will be going to be fixed here. I just select a corner rectangle. I create a center line over here. So now I will give the constraints by giving the dimensions. I will just use like 100 mm. This length I use like 200. And from this edge to this edge, the distance is also important that I have to provide. Then to roller to enter in, I just take one more center line. Now I unwanted area, I trim it off. So when I trim it, the relation is gone. So I provide the relation again. So this is freely moving, which means it's not get constrained. I just constrain it again. Now I will mirror the sketch itself directly. So the thickness I will be providing. Now I have one thing, if you observe, I have not merged it. If it is merged, you can see like it will be acting as a single part. Without merge means it will be a different part which has been welded arrangements and all. You can make it without merge only, so that you can create a separate drawing for these parts also. Okay. One more thing I do is I will just show you creating the planes. If you select the plane, you can create a plane exactly at the middle by selecting both opposite faces. Then earlier I have shown you the sketch mirroring of sketch. Now I will show you the mirroring of the feature itself or the bodies itself. I have first step is I have to select the plane, then I have to activate these bodies to mirror, then I have to select this and this. It has been mirrored. Now the very next step is I go to hole wizard. This is mainly for creating the holes. I need some tabbed holes to mount on this. So for that, first step I create a tab, go to hole wizard, and I will select like ISO itself. Here it's like hole type I have to select. That I select it as a straight tab. And the tab size, there are fine thread and coarse thread. Fine thread will have more threads, more number of threads, and it can withstand more forces, or the thread will withstand more force. But usually in the coarse thread, then less number of threads will be there, but it will withstand very less thread. But widely used is coarse thread only because it's cost effective in manufacturing also. So I go with M6, I select the positions. Before that, I can do one thing. I'll just draw one sketch, center point sketch. Then I go to features. Hole wizard. I automatically created the hole. Okay. Next, I will create one mounting plate also. Here it is required. So onto that mounting plate, the bearing will be there. Inside that, the roller will be there. So how I do is I just go to sketch directly and create a plate. This plate can be dismantled. So I will assume it as a 25 mm roller is getting assembled over here. So I just creating a plate of 15 mm thick. So here we have a tabbed hole. In this plate, we should have counter bore. So how I'm going to create counter bore is just going to hole wizard. Then I have to select the counter bore option here now. And here hexagon socket head screw. That is the screw I'm going to use. I'm just going to select the positions. When I place my cursor over here, automatically it shows the center point. So the counter bore plate is also been created. Into that, the screws will come here. It will have a clearance over here. The screw will sit here and get assembled with here. And to avoid the position change between these two, again, two doubles are required. Doubles is used to whenever most of the times we have to remove and assemble here. For an example, you will be having a bearing in this plate. You will be removing from the assembly and assembling it back continuously. You will be doing it. So whenever you remove and assemble it back, the position will shift because the screw has a clearance. For an example, we use 6 mm M6 screw, but the diameter here, if you see, 6.6, which means 0.6 diametrical clearance it has. 0.6 diametrical clearance means it can move 0.6 anywhere in any of the direction X, Y, Z among them. So to avoid that, what we do is we used to use two number of double holes also we use. Again, just remember that there will be two doubles which should be diagonally positioned. So usually you will not be positioning it in a linear straight line. One double, if you position here, opposite double will be in the opposite direction. Okay, in a diagonal way, you will be positioning two double. Okay, next what I will do is I'll just quickly mirror this. And also I will create a plane over here also. Now due to the time constraint, I'm just skipping the double. Sorry, the plane should be, and bodies to mirror should be this as well as this. So if you make mistake in selecting the plane, here the secondary phase has been selected, that's why that it is being created. Now I'm going to create a roller over here. So separately I will create a roller and I will make it as an assembly and show you, so that I will stop here. I will make some folder. It's a base frame. Okay. Now I will go with the roller, or I will take this to an assembly first. And you can able to create in assembly itself the part model. That approach also I will tell you now. New assembly. Here insert components. You are inserting the base frame. You don't directly click here. What I suggest is go here, click on this feature manager. You will get this feature manager 3. Click on this origin, so that this XYZ plane will get aligned with the XYZ plane of the base part which you brought into the assembly. Now what I will do is I will give insert component, new part. So onto this frame, I'm going to create a roller part. Just placing my cursor over here. Then it will be usually of a tube. So I just offset it. Offset by 5 mm thickness. I assume my roller has a wall thickness of 5 mm. So again, my roller should have an end cap. So what I will do is I'm extruding it. If I do extrude directly from this face, it is getting extruded. So there is an option called offset. So if I use this offset, if I give some 10 mm, you can see that there will be automatically a gap will be maintained between my sketch to this roller face. Okay. Then there is an option I can pull directly through here also, so that it can extrude it. So I just randomly extrude it some dimension. Why reason is I want to know this distance. So 10 mm gap is required here. So 56 is there. So 46 mm still it needs to be extruded. So I double click here and add 46 mm. Okay, this roller is being placed. So now I can open this. I can save it as a separate part also. I mention it as a save as new. I can give it as a roller. So it gets saved as a separate part also. Okay. Now I will do one thing. Individually one part I will create and I will bring in and assemble here also, and I will show you. For this, what I need is this diameter. Inside diameter, we all know that it is 70 mm and this thickness is 10 mm. So I enter into new part. I go to a front plane. I draw a center line. First vertical center line and the horizontal center line I draw. If I draw something angle, I can make it an horizontal by giving the constraints. Next, randomly, what I do is I just draw the cross section. I'm not worried about the dimension. After that, I can go with smart dimension. I can select the center line. If I place this side, if I click here, I can enter the radial diameter. If I click outside the center line, I can directly enter the diametrical dimension. So diametrical dimension is 70, and this wall thickness is 10. And this diameter I need 25. And this length I need, suppose 50, I will assume for now. And here one more thing, I will just use the step also. Now it exactly enters into the pipe, but what I need is I'll just delete here, do some changes in the line. I consider this as a 70. And this as 80. And this dimension as 6 mm. This dimension as 4 mm. Still you can see that it's moving it, which means it's not constrained. Which area is not constrained also it is showing. So this is not constrained. Sorry, I have to make it as a vertical. Now it is fully constrained. So I go to revolve. I created the part. Now I will just save this part as end cap. Now I want to bring this part into this assembly, this area. So how I bring it, I just use the insert component part. Then I select this particular part and I just give mid. Then this face will be the touching faces I have to select. That's all. Now hope you understood why I provided that step. Take section and show you. It's getting guided over here and this face act as a stopper. Okay, and there is a gap maintained over here so that it's not rubbing against each other. And here I have to put one bearing. That also that will be my next step. So the first step is I'm going to mirror this component. So before mirroring here, the end cap I mirror first. If I go here, it will show. If I want to reverse the mirror, there is an options over here. You can able to see the position is getting changed. But actual requirement is this, so I go with this itself. I can do linear pattern or even mirror. Mirror also works for me. I select the plane, then I go to mirror. Then I created the rollers both the side. For easy understanding, I've changed the appearance. Okay, I'll just apply the material here. Plain carbon steel has been applied over here. So the plain carbon steel is the low carbon steel material, which is not recommended for hardening. Most of the time we use as it is only, because when we try to do hardening of this plain carbon steel, which is the low carbon steel material, it's a mild steel also sometimes called, it will take more costly. And even medium carbon steel can be done case hardening, like gears, double pins, the surface, whichever is contact, which needs to be hard, and inside core should be soft. For such material, you will be doing the case hardening. Full hardening will be done for most of the cutting tools. Wherever the punch and dice, whenever you do, it will be completely hardened because we have to regrind it. When you regrind also, whenever the punch worked for some components, some number of components, like 10,000 components or 20,000 components, it will be resharpened and it will be reused. So that time still the inside surface also requires hardness. That time we will be going for the full hardening. So usually the mild steel material will be used, or the low carbon steel material or plain carbon steel material. It will not be hardened itself. The bearing and all, the bearing will be of case hardened material, which is of medium carbon steel. Usually the gears will be of medium carbon steel. So next step is I'm going to create a belt for this. So again, what I'm going to do is I'm just going to use the insert component, new part. So directly into the, for easy sake, I have shown you how to create separately and get assembled here, and directly creating here also. Once again, I'm creating it directly over here. Select this particular plane. What I will do is now I will convert the entities. So when I select, automatically the edge get converted. The same thing I do it over here also. Convert entities. I select this edge of this feature, so automatically converted onto the plane. Next step is I just make a tangent line. And the bottom also make a tangent line. And connects to these circles. Then the unwanted area, just trim it off. Now I offset this loop by some 5 mm thick. Then I extrude it. So what earlier I used blind, so I given dimension. Now I give up to surface. And select this surface. Okay, I'll do one thing. I will just give blind itself. So 310, and direction 2 also the same 310 I use. I created a belt. Okay, now I'll just open this and save it. Next, suppose bearings and screws, if something is required, I can use this toolbox which is available in the SolidWorks itself. You can click here, you can find the toolbox over here. You can find add-ins now. Automatically you will get various standards. Suppose if I go with ISO standard and ISO standard bearings, again the ball bearing, all kind of bearing. I use angular contact ball bearing which can take radial and axial load. Radial bearing will take radial load and axial bearings will take angular contact bearing will take radial and axial load. Here, since it is going to have both kind of loads, I take angular contact ball bearing. So here you have to give just the parameters, various parameters, like what is the size, bore diameter, ODID. So 2230, it's already all standard parameters are available over here. Suppose if I need 25 mm bearing, the last two numbers will define the bearing diameter. So then OD and thickness, if this feels okay, just give okay. The bearing is been created instantly. Then you can save this. Take it to the folder. Rename it. And just give underscore bearing and save it. Now you know the thickness is like 11 mm thickness. It was showing there. And this OD is 42 and ID is 25. So what you have to do is you have to do this changes into this plate also. So just going here and creating the cutout over here. .42 and I'm just going to cut it to 11 mm depth. So here, make sure you have sufficient wall thickness. Since now due to time constraint, I just leave as it is only. So together I can cut both of the things. What I will do is I will give equal constraint for this. So once again, I need not to make the changes. One more thing I can do is I can move it. It will allow me to rearrange the feature tree also. So I can rearrange and I can able to mirror it also. So I'm not going to, I'll just select the plane. So what I'll do is I select this edge, right click. Again, convert entities I do. Sorry, I have created already this. So this won't work. Convert entities, and once again I will make a cut over here. For that, quickly I will just draw a circle and give equal. Why I give equal constraint is in one area, if I make the changes, automatically it will get reflected in all the areas. This side it's not got selected because here only one body is got selected. If you give all bodies, then you can see the cut over here also. Then I quickly go to sketch, convert entities. Now I go to convert entities and just convert this. You can see that the sketch has been transformed. Extrude curve, 11 mm, I cut it, save it, I close this. You can see here it will get automatically updated here. You can see here it's got automatically updated. Now I just give insert component. I bring the bearing. Here, while designing, you should make sure, like, I will just isolate this and will show you the bearing, and this I select, right click. There is an option called isolate. You can see here the backside surface of this plate is touching the inner race and outer race. It should not touch actually. So these are all the small things, but you should take care. It has 30.1, which means minimum 32 mm dimension cut it should have. So what I mean to tell is I'm talking about this dimension. So this is the core. So if I make it as a 32, you can see here a small step has been created in the assembly. From this side, you should be able to see the inner race. So inner race will be free to rotate. Okay, right? And I hide this end cap, that end cap I unhide. So the belt with roller I have created. The very next step is, I think we have less time. I will try to close at the earliest possible. The motor mount plate and gearbox. So gearbox, even the open gears only if you are planning to create. Quickly I will show you how to create the gears also. The same ISO, if you toolbox, the first step is if you go to toolbox, automatically you can select. There are various standards already available in the inbuilt in SolidWorks. You can go to power transmission, gears. Here, if you have various types of gear are available, per gear, right click, create part. So automatically it will take you to the spur gear. So the module into number of teeth will be the pitch circle diameter. Suppose if I select module 1 and the number of teeth as a 50. The PCD will be 50 mm. So instantly I just created the gear. Here again the pressure angle, the standard angles is being shown. Then the face width, this width, how much is required, that I can mention. Suppose 15 mm means if I change it to 15, you can able to see it is getting increased. Then the shaft diameter, which is nothing but the ID of the gear. So we have a 25, so 25 I select, so automatically. Whether keyway required, if it's a single keyway, you can select automatically created, or double keyway means automatically. And number of teeth to be shown, which is nothing but the 50 teeth needs to be shown. Everything you can just entering the parameters, instantly you can able to create it. Now the gear is being created. Suppose as per our calculation, 1:6 ratio gearbox is there, which means here we have a 50 teeth. The other gear should be of 600 teeth. Then only you will be achieve that 1:5, 1:6 with the spur gear arrangement. But most of the time we will be going with the warm gear arrangement, where you will be in the small area, you will be getting the high gear ratio or planetary gear arrangement. These two gearboxes, you will be getting very high gear ratio because you can see like here it consumes PCD is 50 mm. The other gear, if I draw with 300 mm, the PCD will be 300. The center to center distance will be 150 plus 25, which is half of this. 175 will be the center to center between this thing. Okay, so now I will go with the spur gear only, and I will just create it and show you now. Save as new. Gear 150 teeth. Again, I just go to insert components. So I'm not making the keyways due to the time constraint. Okay, the shaft should be actually projected. That also, excuse me. And the one more gear will be there. Then motor mounting frame will be there. So with that, I will stop this and we'll go with the rendering also. Within another 10 minutes, I will close the session and will be open for the Q&A. As we selected already module 1, for this also module 1 should be there. There should not be any change in module. So in order to achieve 1:6 ratio, I am going with 300 teeth. Okay. So such a huge gear we have to create. That's what I'm telling. If we are going with the worm gear or planetary gear, very compact space only, we can achieve this 1:6 ratio. Or two sets of gear set. First 1:2, then again from there like one more set of gear ratio. If you provide, then multiple product you will be getting. Actually, what I have to do is I have to exactly maintain the pitch. Pitch is nothing but the center to center, which is nothing. PCD of this will be 50 and PCD of this will be 300. So half of this 150 plus 175 I have to exactly maintain here. Then on to this, a motor has to be connected. When the motor is connected, then this works. That's how the arrangement should be. So due to the time constraint, what I'll do is I'll just stop the modeling here, save it here. Now we will go with the rendering of this part. Suppose this belt, I just make it, if it is of a material is of some rubber, we will assume it as a rubber itself. You can apply material, but just by right-clicking on this material. There are various standard material is available over here. Or here you have an appearance option also, where you can go to rubber, whatever the finish you want. Even some textured finish if you want also, you can apply. And if you want this to be painted, you can go with painted. You can expand this. The entire tube, one color I provide. And low gloss, I will use it for this. I can use a different color over here. Okay, and for gears, apply these colors, everything you can do it in Visualize Connected also. Just chrome plated I apply. And for rollers, I apply steel, polished steel. So automatically all this area it's got applied. Next, suppose if I want to apply add some logos, I can add it in the decals. Now I'll just add whatever the standard logo which is available here. First I select the face. Then I go to mapping. I just select the part and face only on this surface. I can change the angles also. The size, I reduce it now. Okay. For some reason, I'll just go to the part itself directly. Here I'll apply the decals once again. It was not in the assembly, I just tried. It was not coming properly. Yeah, now I got it properly. 270. Or here only in the mapping, I can change the value. I can increase it or decrease it. Okay, it has moved the opposite side. Just I go here, I can edit it. Instead of this space, I just select this space. I can drag and adjust also. That is also possible. I just save here and close. It will automatically get updated here. Now I will take you to the rendering environment. First, I can give the orientation also here, which orientation I want to do rendering, everything. I can set it here only. Now I set the orientation here only. In this orientation I want to do rendering. So all these things, whatever I have done over there, that can be in SolidWorks, that can be done here also. Just since everyone will be aware of SolidWorks, I just have done that there. Here I just SolidWorks documents I select. Assembly1 is the file name. So another, meanwhile, once I made the setup, I can take up open for the questions. So here it's in a preview mode. That's why it is showing like that. In accurate mode, it will show properly. But once we rendered how the image comes, we'll see a quick rendering setup I make. So the media I need it in JPEG. I will log the aspect ratio and I will just mention like 3000 pixels. So automatically the width will be taken. The quality and the render passes, I make it as just 50 for trial purpose. It will be, if the more number of passes, more time it will take. Since we have a time constraint, just start with 50 or even 35. I just select. And where it need to be saved, what is the, everything I can define here. Output folder, I just select conveyor assembly. And file name I can provide and just give render. Fine. Like I'll be open for the question. If you have any queries, please let me know. Please drop in the chat box. Some questions I can see. Where is the features which used to set lines parallel to each other? Okay, actually, this my system got slow now since the rendering takes So you are looking for the just if you right click on angular line you drawn, it will ask can able to make vertical or horizontal, that you can use it. Or if only one line is parallel means you can select that line, press control and click on that new line which you want to make it parallel, that will get automatically parallel. Okay, animation video. As I told, I thought of starting with some basic introduction session. Whatever the within this 1.5 hour, whatever is possible, I just created and shown you. We will have some further on also along with the idea team. So during the time, I like to share still more knowledge of mine, whatever I have learned during my experience. Sure, we will make so many animation videos and simulation also. Due to time constraint, actually static simulation we have planned. That unfortunately I'm skipping it today. So we will have more further session. That time I can able to explain you. So for the 30 passes, it's taking this time. So when this is 1,000 or 2,000, because it's high out 30 or 50, you see how much time and what is the image quality. Still you expect more means, then you make it like 100 or 200. So first you get a rough image, then you increase the passes and rerun it, then you arrive at the proper quality, whatever the quality you expected. That will be the right one. Instead of initially itself giving the 1,000 passes, after running the 1,000 passes with like orientation not correct, or some material assigning we might have missed, all kind of error we might be figured out. There will be last minute basis for us. We have to do everything. Instead of that, just give some rough minimal passes and run it. Then if everything is good, then you give more number of passes and run the 10 process. Okay, we'll wait for some couple of minutes to see the output. That's all from my side. Thank you all for your patience. Thanks for your time and listening me last 1 hour for 10 minutes. Have a great day. And whoever wants to wait and render images, please be online. That's all from my side. If you are busy with something or something else, you fill the attendance, you can leave the session. If you're a high or busy with some work or something. Thank you. Thank you. Thank you. If someone is interested, I will be online. I like to be online for 5 more minutes. 3 to 5 minutes, the rendering will complete it. I can show you image quality so that. Yeah, sure. Okay, presentation someone has requested. I will share with Mr. Zeeshan. He will be circulating with the team. You can see here this yellow will get green. Until that you have to wait. Once it is completed, once completely green, you will get an option to open here the folder. From there directly you can open the image and you can see how that is. I think another 30 to 40 seconds it will get over. Yes, now it's completely green. You can see here. This is the final rendered image. Still, I can see some blurriness when I zoom it. That I can increase by increasing the number of passes. I can able to change it. The texture, all these things. If it is okay, then I can proceed with doing the changes. Even some colors, if I want to modify now, I have an option to modify and do it. That's all. Thank you. Thank you very much. I will stop sharing. Have a great day ahead. Bye. Thank you, Zeke. Thanks, Idea team. Thank you all for giving me the opportunity. I look forward for still some moderate, mid-level and advanced session also. We will catch up together. Thank you all for attending the session.